Hello everyone, welcome to my YouTube channel. This is Shikha Sambarkar and today our topic is Computer Network Part 9. Under this topic there is a subtopic Transmission Media Part 5 and under this we will discuss today about unguided media radio wave. Yes, this is our topic today, radio wave. This video is helpful for class 12 CBSE students, those who have opted computer science and informatics practices as an optional subject. And other students also can watch the video, those who are interested in this computer network field. So let's start our topic, radio wave. Before starting the topic, first we should know about transmission media. Yes, transmission media. Here one image is given. You can see left top corner, sender PC is there. And another side receiver PC is there. Sender means we can say source system, source computer, and receiver means destination system. So from sender to receiver we can send one message, we can send messages via transmission media. This transmission media can be wired or wireless. So here in this video we are going to discuss about wireless transmission media, that is radio wave. There are 2 points are given. The cables that connect two or more workstations. Workstation means node or system or computer. If a system is connected in a network, at that time it is called workstation or node. Okay. So the cables that connect two or more workstations or systems are the communication channels. Communication channels are also called transmission media or connecting media. Okay, now types of transmission media. We can group a transmission media in two categories, guided media and unguided media. The guided media includes cables and unguided media include waves through air, water or vacuum. Basic types of guided media are twisted pair cable, coaxial cable and fiber optics. Basic types of unguided media are infrared, radio wave, microwave link, satellite link. So here in this video, we will discuss about unguided media, radio wave. So let's start the topic. Here, there are some images are given. 3 images are given here. So you can see, you all are aware about this. These are the images of radio. Everywhere we are using radios nowadays. So what is radio? Radio, we can say it's just an activity of sending out programs for people to listen to the programs that are sent out. Or we can say this radio, it's a piece of equipment or a device that is used for receiving or sending radio messages or programs. So we all are aware about this term radio. I have included these images here. Now radio waves. So we understand the term of radio. We all are aware about this radio. Now wave means what? A wave can be described as a disturbance that travels through a medium from one location to another location. We can understand it like this. So there are a special type of wave that can travel without a medium called electromagnetic wave. And these electromagnetic waves are waves like radio waves and microwaves. So here in this video we are discussing about radio wave. Electromagnetic waves means, actually electromagnetic waves are formed when an electric field comes in contact with the magnetic field. They are hence known as electromagnetic waves. Electromagnetic waves are formed when an electric field comes in contact with the magnetic field. So here radio wave is an electrical wave. Now here you can see 2 images are given which are showing the concept of radio wave. In the first image you can see that blue circle like that. So this radio waves are omnidirectional. Omnidirectional means they travel in all the directions from the source. So these radio waves are omnidirectional. Omnidirectional means they travel in all the directions from the source. We can say it radiates and receives energy equally in all horizontal directions. It provides a 360-degree horizontal radiation pattern, and it means when an antenna transmits radio waves, they are propagated in all directions. So these radio waves are omnidirectional, means in they travel in all the direction from the source. So you can see these two images are showing the same concept of omnidirectional. So these radio waves are omnidirectional, means they travel in all the directions from the source. And one more thing is here that just like infrared, radio waves are also invisible to naked human eye because its wavelength is much more longer than those of visible light. So these two concepts are here, that these radio waves are omnidirectional and it is invisible to human eye. Now some points are given here related to radio wave. First is the transmission making use of radio frequencies is termed as radio wave transmission. Radio waves are electromagnetic waves that have wavelengths between 1 mm to 100 km or 300 GHz and 3 kHz in frequency. Radio frequency is easy to generate because it has large wavelength and can travel long distance. We all are familiar with radios and their working. Yes. When certain radio frequencies are allocated to private business for direct voice communication, they can make use of it for private business purposes. In general, private citizens and business users are licensed to operate in the range of about 10 miles. So these are some points related to radio wave. Some more points are given here. First is all radios today, however, use continuous sine waves to transmit information like audio, video or data. Each different radio signal uses a different sine wave. Frequency, and that is how they are all separated. Any radio setup has two parts, transmitter and receiver. Any radio setup has two parts, transmitter and receiver. The transmitter takes some sort of messages, encodes it onto a sine wave and transmits it with radio waves. And the receiver receives the radio waves and decodes the message from the sine wave it receives. Both the transmitter and receiver use antennas to radiate and capture the radio signal. So this is the process here. There are two parts, transmitter and receiver. Transmitter takes some sort of messages and encodes it onto the sine wave and transmit it with radio waves. And at another end, receiver receives that radio waves and decodes the message from the sine wave it receives. Both the transmitter and receiver use antennas for this purpose. So this is the working of transmitter and receiver. We can see one image here. Here you can see image. One image is here, transmitter and receiver. At the left side you can see transmitter and right side receiver, and in between waves are going on, and both have antennas. Both transmitter has one antenna and receiver has another antenna. This is the concept of transmitter and receiver. Now there are some advantages of radio wave. First is radio wave transmission offers mobility. Mobility means we can say here changeability or inconsistency, versatility. So, radio wave transmission offers mobility or changeability. It proves cheaper than digging trenches for laying cables and maintaining repeaters and cables if cables get broken by a variety of causes. So it is cheaper than the cables like twisted pair and coaxial cable and fiber optics also. So third point is it offers freedom from land acquisition rights that are required for repairing the cables. Fourth point is it offers ease of communication over difficult terrain. Difficult terrain means we can say difficult areas, regions. It offers ease of communication. So these are the advantages of radio wave. Now some disadvantages of radio wave. First is radio wave transmission is an insecure communication. As radio wave is, we have seen that it's an omnidirectional and this is wireless transmission, unguided media. So this is insecure communication. Second point is radio wave propagation is susceptible to weather effects like rains, thunderstorms, etc. So it affects when it rains or thunderstorms is there. So definitely it affects the communication. So these are the two disadvantages of radio wave. I hope this video is helpful for you all. Thank you. Please like, share, comment and subscribe this YouTube channel presented by Shikha Sambarkar. Thank you.